welcome to lesson 2. In this lesson we're looking at ways of displaying data, and you've seen lots of different kinds of ways to sort data before, right? And bar graphs and circle graphs and line graphs and all those kinds of things. We're going to add 2 kind of new things, new ways of displaying data in this lesson. And they're actually both can be built on the same data, so they're just kind of aesthetically different, but they look or they come from the same place, and we would set them up the same way. So these are histograms. This question here has histograms in it, and frequency polygons are the kind of line graph version of histograms. So a couple of things that I just want to point out that aren't in your notes is these are not actually bar graphs. They look like bar graphs, but they don't function the same way as bar graphs. And technically they're different. Aesthetically, they're slightly different in that when you do a bar graph, you're not actually supposed to scrunch the bars right up against each other like this. This is a histogram. So right away I can look at it and I can see there's no spaces in between the bars. So I know that this is a histogram. If it was a bar graph, technically you're supposed to have spaces in between the bars. So, I mean, that's a technicality, it's no big deal. But I don't want you to think that these are necessarily bar graphs. Bar graphs function a little bit differently than these guys do. Okay, and frequency polygons have the exact same data on them, but instead of representing them in bars, what we would do is we would, instead we would put, instead of like drawing a line and making a bar that goes up to a certain value, we would put a dot in the middle of the interval, and we would connect the dots with a ruler. Okay, not freehand like I'm doing here, but actually with a ruler, and we would carry these guys down to all the way to the x-axis. So you can see that it actually makes a polygon, right? It makes a straight-sided shape that's all closed in. Okay, and that's why you want to make sure you carry it down to that x-axis and close in that polygon. So maybe you can kind of see that kind of weird, almost a triangle kind of shape instead. That's what a frequency polygon looks like, but it's built off the same information that a histogram has. So the first thing we want to do is we want to be able to read histograms. And remember that these guys are actually just telling us how frequent a piece of data shows up. So how often do we see a particular range of data? How often do we see, in this case, earthquakes, magnitudes fall between 1 and 2 on the Richter scale, 2 and 3 on the Richter scale, 3 and 4, 4 and 5, 5 and 6, and potentially 6 and 7. Okay, so how often do earthquakes show up in a year in Canada? And you might not have known that there were actually earthquakes in Canada, but on the west coast there's actually earthquakes quite often. They're just usually not very significant in magnitude. Okay, so these histograms show frequency, and frequency polygons obviously show frequency as well. The higher the bar, the more frequent something happens. Okay, and like all good representations, all good graphs, we have really good scale. So once we start counting by a certain number, we keep counting by that number, right? And all of our intervals are evenly spaced and represent the same range of data. Okay, so again, we're trying to eliminate squish them in certain places to make them look different, and you might have done that in grade 9 as well, made some misleading graphs. It's kind of a fun activity, but these are just information put out there and displayed pretty accurately. The higher the bar, the more frequent something happens. So if we look at what happened in 2005 in Canada, the most frequent earthquake, there were 20 earthquakes in Canada in 2005 that had a magnitude of between 3 and 4. There were no earthquakes in Canada in 2005 that had a magnitude higher than 6. Okay, and so we're reading frequency up this axis and magnitude along this axis. Okay, and there's a whole range of numbers in between 1 and 2. So if there was an earthquake of magnitude 1.8, it would fall in this bar here, right, in this particular space. Okay, so the question is, in which of these years from 2005 to 2009 could have had the most damage from earthquakes? Well, it's a little bit tempting actually to look at 2005 as being particularly damaging because there were so many earthquakes, right? There were, 20 plus 11, plus 4, 35, 40, 43 earthquakes that year. That's a lot of earthquakes. So it looks like there was lots, but if you notice that the higher bars actually have lower magnitude. So we want to look at damages caused by the strength of the earthquake. So we want to look for years that had the highest magnitude earthquakes. And that kind of is in this range right here. Okay, 2008 seemed to be a particularly rough year for earthquakes in Canada in that we had 5 earthquakes that were between 5 and 6 on the Richter scale. And there were 4 earthquakes that had a magnitude between 6 and 7. What's really interesting too is that for every jump in value on the Richter scale is a 10 times increase in the magnitude of an earthquake. So a magnitude 7 earthquake is 10 times stronger than a magnitude 6. And a magnitude 7 is 100 times stronger than a magnitude 5. So it's a really neat set of data. But we can see that 2008 was the most damaging year. Okay, and our reasoning and our justification for that would be because it had the most frequent amount of higher magnitude earthquakes. Okay, hopefully that makes sense. Now let's go into the second part of this problem. The second part of this problem is a whole bunch of data here, and it asks you to create a frequency distribution. So this is the flow rates for the Red River from 1950 to 1999. There's a very big flood in Manitoba, and in 1999 there was well, I think 1999 was okay, but 1997 was a bad year. So we've had quite a few floods in and around this time. So when we look at this this data, which actually is so much data, we split it into 5 charts. It's really hard to make sense of what's going on in this information. So what we want to do is we want to sort it, and we want to look at how we want to make a picture of it so we can interpret it much more easily. Now Excel will do this for you, Desmos will do this for you, but we're not going to be making too many of them, and I definitely want you to know what's going on behind the scenes. So we're going to do a couple of these by hand. You can play around in Desmos, and if you know anything about Excel, you can make a histogram pretty easily in Excel. The ones that I made in your notes booklet, I made in Excel pretty easily. I had to, cut a few corners here and there. They're not perfect, but they were made pretty fast. But we're going to make these guys by hand. Okay, you're going to have to make a couple by hand in your independent practice. So good that we're kind of walking through this. Okay, our frequency distributions and our frequency polygons and our histograms, we need to decide how many intervals of data that we want. And your notes say that a range of 5 to 12 kind of intervals is a good range. So this is a lot of data, so we're going to pick 10 intervals. Okay, so we're going to take all of this data and put it into 10 even amounts. Now, how do we know what those amounts are? Well, what we want to do is we want to find the range of our data. So we have to go through and we have to find the highest and the lowest pieces of data. So the highest piece of data, if you kind of go through this whole list, is the 1997 flood. Okay, so that's our highest amount of flow going through the Red River. It was a pretty crazy flood. If you ask your parents about it, I'm sure that there will be an interesting story out there about what they were doing in the time of the flood. And then because it's a range, we take our highest and we subtract our lowest value. So our lowest value is, let's see, if we look around, we're looking at flow rates, right? So where's our lowest flow rate? Looks like 1981 was our lowest flow rate. That's our lowest number. So when we subtract those, that means we have a range of 4,428. Okay, so that's our range. So we find our range, we decide how many intervals we want, and in this case I'm choosing 10. Okay, and it's kind of up to you what you think. And if the question doesn't specifically tell you how many intervals, then picking 5 to 12 is a good amount, somewhere in there. Okay, and then what you do is you take your range and you divide it by how many intervals. So you're taking all of your data and then dividing it into how many intervals you want to see how big each interval is going to be. And when you do that, you get 442.8. And that's a very specific number, and I don't necessarily want to count by 442.8. So I'm just going to round this to a reasonable number like 500. Okay, so that means I'm going to have 10 intervals, and I'm going to make this kind of a frequency table where I have my interval here, and I'm going to measure my frequency. And what I'm going to do, probably didn't leave myself enough room to make 10 intervals. 1, 2, 3, 4. Nope. 5, 6, 7, 8. Maybe I'll squish 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll split this one in half too. It's very ugly. I'm sorry. Okay, so my first interval, I want to start at 0. So it's going to be from 0 to 500. Second interval is 500 to 1,000. Okay, and so I'm going to have intervals that are 500 units big. Okay, so here I have my table all set out with all of my intervals on it. And what I want to do with this guy, I'm going to zoom out a little bit, is I have to go through each piece of data and sort it into which interval it belongs into. Okay, and so the easiest way to do that is kind of just do tally marks that will add up at the end. So I'll do the first couple in a second, or here for you, and then I'll pause it and I'll fill in the rest. You don't have to watch me go through all this data. This can be very time consuming, and this is where technology really is helpful. But I don't want you to use technology without knowing what the technology is doing. So we're going to work through this one by hand. All right, so let's take a look at the first data. 1950, there was a flow rate of 3,058. So that belongs in this range here. It's between 3,000 and 3,500. So I'm just going to put a tick mark there. Okay, 1,065, and you might want to check these guys off as you go through them because you can get lost pretty easy, especially with this much data. 1,065 belongs in the 1,000 to 1,500 category, as does the 1,008. 357 goes in our first category, but 524 goes in our second because it's bigger than 500, right? And then 1521 goes in the 1,500 to 2,000 category. And I think you could probably figure out what I'm doing for all the rest. Okay, so I finished going through all of the data and have put tally marks for each piece of data. So all I'm going to do is count up my tally marks here. So 6, 11, 9, 14, 4, 1, 3, 0, 0, and 1. Okay, so that's how frequent each of these particular flow rates were. So now our job is to turn that into a histogram. Remember, that's the one that looks like a bar graph, and also to turn it into a frequency polygon. And remember, that's the one that kind of looks like a line graph. I mean, it's not a straight line, but it looks like a line chart. Okay, so how we want to do that is we want to map out scales on our y-axis. We always have frequency. I didn't leave myself a lot of room here to write this, so I'm going to squish that in there. But our y-axis always has frequency on it. Okay, so that frequency goes with this graph here. Okay, and our highest value is actually 14. So we need to be able to count up to 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, we can start at 0 and we can count by ones here. Or, I mean, I'm counting by twos, but each space represents one amount. Okay, and so remember that these both tell the same story. Histograms and frequency polygons kind of tell the same story, except they just have different shapes. Okay, so we can just use the same scale on both of them. Okay, I have 10 intervals along the bottom, or 10 intervals in my data. So we always put that on our y-axis. So how many spaces? I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 21 spaces. So I can use 2 spaces to represent one interval. Okay, and so again, we always want to kind of count at 0. We want to start at 0. This is going to be 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, and 5,000. Wow, I actually made that work. And what information is, remember, we always label our axes on our scale. This is our flow rate in meters cubed per second. And we always have units. Okay, so I have both of my my graphs labeled with good scale, good information on their axes, and now I just have to put the data in. So my histogram, I'm going to use a pencil just in case I make a mistake here. My histogram, my first interval has 6 pieces of data, right? So 6 times in those 50 years, we had a flow rate between 0 and 500. So I'm going to make a bar that goes up to 6, okay? And then shade that in. For the second interval, that happened 11 times. So I just need to make sure my bar goes up to 11. Okay, so it looks just like a bar graph, but again, we're squishing these together, no spaces in between them. The third interval happened 9 times. We had that flow rate range 9 times. So we just make a bar that's 9 tall. Then we have 14. Okay, and then I'll keep going and I'll fill in the rest of this. Okay, so this is what our histogram looks like for our data. Okay, so you don't have to spend too much time coloring it in, but our information needs to be really clear to see and easy to read. So, I mean, it takes a lot of steps to make this histogram, but if you compare it to just rows of data, this picture makes things a lot more clear, right? Thankfully, we've had very few flow rates in the last 50 years, or in that 50-year range, that were this high. Okay, and you can see that most frequently the flow rate is between 1,500 and 2,000 cubic meters per second. So if you're going to make decisions about, flood measures, or, how high, if you want to build any, kind of flood protection in your town or in your community or even in your own personal home, what do you want to plan for? What's going to be the most common? And, these guys show up occasionally. These higher flow rates show up occasionally, but this guy's a real outlier here, and that was the flood of 1997. That was called the flood of the century. So it doesn't show up nearly as often, right? This amount of water doesn't show up very often compared to the rest of it. So we can see all of this data, we can see it really quickly and easily in our histogram. Okay, how do we turn this into a frequency polygon? Well, I think I'm going to try to do this. I'll try to do it in pencil. Hopefully it'll show up. Okay, so same thing, but instead of drawing a bar in the middle of the interval, we're going to put kind of a dot at the 6. So we're halfway in between the 0 and 500. So we're right in the middle of that interval. The frequency is 6. So I'm going to put it kind of a dot at 6. And then halfway between the 500 and 1000 interval, the frequency is 11. So I'm going to put an 11, right? I'm going to put a dot at 11 halfway in between that interval. Okay, so I'm going to go and do the rest. Okay, so this time I've put dots instead of making bars, and what I'm going to do is I'm going to grab a ruler and I'm going to connect the dots, but because it's a polygon, and that should give you a little bit of a clue in that we have to close the shape. So we always kind of want to go down to 0. Okay, we don't just start our polygon up here in the middle of open space. We're going to carry that down to our x-axis. And then after that, we're going to connect all of the dots in order from left to right. Okay, and these kind of look like, if you've seen in the movies, maybe a bar graph or a line graph, like maybe for a business meeting or something, that looks kind of like this, like stock prices or something like that. They kind of look like this. And then for this very last one, we just have this one little blip up here, but we have to make sure we close it off. Okay, so that's what our frequency polygon looks like. So it has exactly the same information as our histogram, but it just looks differently. And what we can do, what's really interesting, is we can put a frequency polygon over top of a histogram. So let's say we had some other piece of data we wanted to compare to the flow rates of the river. We could put that into a frequency polygon and put it on top of the histogram and see how they compare. Okay, so that's how you make a histogram and a frequency polygon. The steps are outlined in your notes. Follow them and practice them. I am going to get you guys to make some of these on your own. Okay, so good luck.